Hello everyone, and thanks for joining this webinar today. My name is Mattia. I am co-founder of SaSi Studio, an architecture startup based in central London. I would like first of all to thank Desktop Engineering and Dassault System for inviting us to present our work here at BeyondBIM 2020, and I would like to thank them also for organizing this event in this digital format. Today I would like to talk about off-site manufacturing and how component-oriented design together with BIM and digital fabrication can create new opportunities for the construction industry.
I would like to start introducing our company and our work. We are a young practice working on residential, commercial, and hospitality projects. Our expertise includes the design of buildings from concept to fabrication, using BIM, computational design, and digital fabrication. We use contemporary design technologies to support the digitization in the construction industry, developing resilient architecture capable to implement new business models already applied in other industries. We investigate the latest trend in technology and how these technologies can impact our society. For example, how architecture can take advantage from technologies like artificial intelligence and big data, or how new trends like sharing economy can revolutionize the way you use urban spaces. For example, the use of new digital fabrication technologies in connection with big data is opening opportunities for mass customization and off-site manufacturing. But to take full advantage from all these technologies and apply them in construction industry, we need to develop architecture projects that fully represent and integrate the current social behaviors responding to the current requirements of our society. In the last century, our idea of city evolved together with the technology and society. We passed from cities organized around a linear concept of time with a rational distribution of functions to our contemporary cities in which multiple layers of interaction happen at the same time across the globe. If we consider, for example, the functional city proposed by Le Corbusier in La Charte d'Athènes, there was a clear distinction of functions in different urban areas. But if we consider the model proposed by Jane Jacobs later on, she reverted this idea of urban model, supporting dense mixed-use developments that could also contribute to improve the safety of the cities. In the contemporary cities, functions overlap in time. Activities happen simultaneously across the world. The boundaries between public and private space are blurred. Architecture should respond with new dynamic models capable to adapt the social behaviors that are constantly changing. We believe that architecture should become more resilient to changes in our society, taking account changes and innovation in social behaviors, many times, for example, driven by innovation in technology. This can happen in several ways. One possibility is to update our business models by introducing more technology in the construction processes. In fact, we are living in a new industrial revolution, commonly identified as Industry 4.0, that is characterized by the use of automation and data exchange in manufacturing technologies and processes. For example, if we consider the automotive industry, that is one of the industries where advanced manufacturing technologies have been fully implemented in the production processes. The first assembly line was introduced by Henry Ford in 1913, making, for the first time in history, quality vehicles affordable to the masses. Since then, in less than 100 years, this industry deeply evolved, reaching a high level of automation in the fabrication process, achieving in certain cases what is commonly defined as dark factory or light-out manufacturing. If we compare this with the construction industry, the level of automation in the construction processes is much lower. Industry 4.0 represents an opportunity for the construction industry that, in our opinion, can be taken by reorganizing the construction process. One strategy to materialize this opportunity may be adopting off-site manufacturing, in combination with digital fabrication technologies, taking advantage by the use of digital design technologies already widely applied in aerospace and automotive industry, able to generate data that can be used to drive the construction phase. In the last years, off-site manufacturing demonstrated to be an interesting field for the construction industry, in which there is room for innovation in several directions. This approach to construction, in fact, allows to achieve higher construction quality, cost effectiveness, and schedule predictability, increasing safety performance and reducing waste and pollution. Off-site manufactured buildings can offer high quality and precision engineering processes and represent an opportunity for ambitious job creation, helping to diversify the workforce, making full use of the high-tech skills of young talents, and training current workmanship with higher level of skills and specialization. In this context, BIM and 3D model-driven fabrication play an essential role to be able to fully deploy the advantages of off-site manufacturing, allowing for high-precision design, high level of coordination, and reduction of clashes, providing all data available for fabrication. Has been highlighted by the Smart Market Report 2020 from Dodge Data and Analytics, the use of BIM and off-site manufacturing helps to reduce costs, increase precision, improving quality, and project coordination. On the other side, we have to consider that when we talk about prefabrication, there is a collective image of this construction technology that is commonly associated with rundown buildings and bad quality of construction. And sometimes this collective image is worsened by inadequate maintenance of certain buildings. But there are also very successful examples of prefabrication that managed to become very important icons for our cities. So one of the first challenges and that we have to face is to propose architecture projects that can highlight the potential of off-site manufacturing, taking advantage of latest technologies, demonstrating the possibility of increasing the quality of the living spaces, opening the possibility to introduce in architecture and real estate business models currently available in other disciplines. In fact, this is another important aspect we have to consider, because in order to deploy off-site manufacturing is required a higher upfront capital investment compared to traditional real estate financial models. And currently, the volume of demand for off-site manufacturing doesn't justify the upfront capital investment. In addition, traditional funding and financial models are not geared to the requirements of off-site manufacturing. This is why at SaSi Studio we are investigating the potential of component-oriented design and digital fabrication to fully deploy the potential of off-site manufacturing. In our design process, we take in account social stakeholders, fabrication constraints, and urban data, and we connect all this layer of information to drive our design decisions. This allows us to create complex layer of information that we can coordinate with the information we receive from other consultants and suppliers and help us in the coordination of the project. In our projects, we aim to offer new living experiences, creating hybrid spaces that takes in account new habits in social interaction. These typologies are flexible and can host different functions. For example, they can be spaces for social interaction, but at the same time, they can be spaces to work from home. These become spaces in which the distinction between public and private is blurred. We are willing to create resilient spaces capable to adapt to different user requirements. In some of our projects, these spaces are created by the combination of modular components, like in this case study in which the facade has been designed using one module that has been rotated and shifted to define the overall massing of the tower. The geometry of the modular component takes in account fabrication constraint using single curvature surfaces and making possible to build all the modules through the use of reusable formulas, reducing wasted material and pollution. Our company has an experimental approach that reflects on the design but also on the workflows that we use in our project. In fact, we adopt latest BIM technologies using cutting-edge tools to optimize our workflow. For example, we do this cooperating with other startups like MKS to introduce custom tools that improve automation and data exchange across different platforms, like the BIM plugin that allows to embed data in the geometry and transfer these across several platforms. In some of our projects, we develop design systems that can be deployed thanks to the use of cutting-edge fabrication technologies based on the use of robotics and artificial intelligence. We work with innovative materials and we test them in experimental projects to explore new possibilities opened by the use of computational design and digital fabrication. In our project, we use 3D models to embed several types of data, and we use them to inform our design. We create BIM models in which we layer the information in different datasets, and we make this model an essential tool for the coordination of the project across all the stages. This type of workflow becomes even more powerful when it's deployed in environments like 3D Experience, in which you can combine different type of data source and elaborate them with several advanced tools, all fully integrated, like for example image and shape and generative design, that allow to create complex geometries and parametric models, generating data-driven simulation and making this data accessible across the project team and improving the coordination inside the team, and also making this data available straight away for fabrication. From early stages of design, our workflow involves the use of environmental data, site analysis, topographic conditions, urban data, and social stakeholders. We use this information as a driver for the design process. In this way, the massing responds both to program requirements and available data, creating high-performance buildings that are designed taking account the end-user requirements. An important aspect of our workflow is the capability of creating virtual reality and advanced CGI images that allow to have the result of this design process available at early stage of the project. This helps to establish a clear understanding of the project and communicating these with all the stakeholders and have a positive impact on several aspects such as fundraising, planning approval, etc. Part of our research and development focuses on developing innovative component-based systems that can respond to urban data and constraints, creating spaces that are resilient to multiple functional scenarios and can be adapted over time. Using computational resources based on artificial intelligence and digital fabrication, we can enable mass customization at urban level, offering unique living experiences to the end users. The use of big data, together with building information modeling combined with digital fabrication, allow us to create high level of customization without requiring the use of expensive construction processes, using different families of components that can be highly customized based on the end user requirements. The use of prefabricated assemblies allow to generate highly customizable buildings that can be easily deployed, adapting to local environmental conditions. The goal is to create spaces that establish with the user a sense of belonging, to build integrated communities in which architecture and society evolve together and learning from each other like a natural ecosystem. We are operating as a studio as a part of a wider network of professionals, suppliers, contractors, and we are open to collaboration with the other companies, investors, and developers that are willing to invest in new technologies and find together new ways of creating and using the space in which we live every day. With this, I would like to conclude this webinar, and I would like to thank you for joining us today. And if you have any question or if you have any further requirement, we can get in touch to our website, or you can ask Bev to put us in contact for the Q&A session. Thank you.